All right, so for number 20, we have this exponential equation, right? Something raised to some power, meaning we're multiplying that over and over and over and over again. And we want to see which one of these values of x will produce a point closest to the x-axis. So first we have to determine, is it growth or is it decay? And really, remember, if it's bigger than 1, it's growth. If it's smaller than 1, it's decay. But just think about what's happening here. If I'm multiplying something by 1/2 and by 1/2, if I'm cutting it in half, over and over and over again, well, that's going to get smaller and smaller and smaller, right? If I take a piece of paper and cut it in half, eventually it's going to get really, really tiny. It's decaying, or it's going like the shape of your left hand, right? It's decaying. So now that we have the shape of our graph, now it's really easy to figure out what I want. Do I want something that's closest to the point, to the x-axis? Then if I want something that's closest to the x-axis, then I want something that's further to the right. Because as I follow my graph to the right, we see that we get closer and closer to my x-axis. As I go to the left, it goes farther away, right? So I want something furthest to the right. So my only goal is now is figure out which of these points is the furthest to the right on this x-axis. And if you're good with fractions, then you can see that 7/8 is the furthest to the right on this. If you're not good with fractions, then you probably want to do a little bit of long division. So 1 divided by 3 would be 0.3. 1 divided by 2 is 0.5. 7 divided by 8, I think it's 0.875, but let's just check. So it goes into here 0 times, so let's add that. And then it goes into here 8 times. So let's just go 1 decimal, even though it goes more. And here 4 divided by 9. So it goes in 0 times, 9 goes into 44 times, so this is 0.4. So which is furthest to the right on the number line? That would be 0.8 is the furthest to the right, which again is 7/8.